With how complex the inner workings of the human eye is, it is no wonder why people want to figure out why they are seemingly limited in their ability to see far distances. Well, today I'm here to help you all in the understanding of this also common wonder. But first, we must travel to our own planet to discover the most limiting factor for seeing long distances. Why is it that we can't see far on Earth? Can we see further in space? Or are we just limited by visual acuity and the quality of our eyesight? Welcome to Waffle with William, episode 29, and the limiting factors behind human eyesight. And here we are on Earth. Aside from obvious visual obstructions, such as trees, buildings, and clouds, there's one major factor that can reduce your sightline: the curvature of the Earth. The Earth's curvature is about 8 inches per mile. As a result, on a flat surface with your eyes 5 feet or so off the ground, the furthest edge that you can see is about 3 miles away. So the distance that you can see is dependent upon your height or the height that you are viewing it from. But what is the maximum distance that we can see on Earth without the interference of these obstructions? In order to answer this question, we will have to travel to the largest land-based mountain in the world, Mount Everest. According to this map from this Reddit user, it shows us that having a perfect line of sight from the very top of Mount Everest would allow us to see a theoretical 340 kilometers or 211 miles, which is a lot more than the previously mentioned 3 miles. However, using this online distance calculator, I can see that this distance value was created from a horizontal line of sight and not a diagonal one. So utilizing the Pythagoras theorem of a squared plus b squared equals c squared, used to find the length of the longest side of a triangle, I can work out the true theoretical distance when using a diagonal line of sight. By plugging in the height of Mount Everest peak at 8,848.86 meters and the distance to the map's furthest point of 211 miles converted to 339,600 meters, we get an answer of 1.154064623 times 10 to the power of 11 squared. Square rooting this value gives us the true theoretical furthest distance of 339,715.2625 meters. So when compared with the original value from the Reddit user, there is only a marginal gain of 115.2665 meters, or 0.0716 miles. This proves that if you know where to look, you could possibly see even further. We've looked horizontally and diagonally, but what if we look up? For the next part of this video, we must leave Mount Everest and leave Earth entirely, because for this we must travel out of the atmosphere and into outer space. The diameter of the observable universe is estimated to be about 93 billion light years across. With just our eyes, we can generally only see a few thousand light years worth of distance, although there are some objects we can see that are much further away. The furthest object that we can see in space from Earth with the naked eye is the Andromeda Galaxy, which is located a mind-bogglingly large 2.6 million light-years away. 1 light-year is roughly equivalent to 5,878,625,373,168.3 miles. So you can do the maths. Having 2.6 million of that number equals to quite a distance. As such, the Andromeda Galaxy, to the naked eye, appears as a fuzzy blob in a particularly dark sky. And it is almost impossible to see Andromeda in an area with high levels of light pollution. But, you know, there's this nifty invention called the telescope, which simply put, magnifies objects. It's pretty much a huge magnifying glass, and as such allows us to see further into space. They work by using curved mirrors and lenses to obtain light from the sky and distant objects, then concentrating this light down into an eyepiece for magnification. Telescopes with bigger lenses collect more light and allow you to see further, and as such, how far you can see with a telescope is determined by 1. The quality of the telescope, because the smoother the lenses, rather than having a rough surface, the less distortion there is on the image, and thus the clearer the image. But 2. The aperture size of the telescope lenses, the diameter of the lens. As mentioned before, a bigger aperture results in more light gain and allows you to see further. From Earth, with a standard 8-inch diameter telescope, you can see objects that are about 8 billion light-years from Earth, such as quasars. Quasars are a celestial object predicted to contain supermassive black holes and may even represent a stage in the evolution of some galaxies. However, with a telescope based in outer space, with a huge diameter of 2.4 meters, namely the Hubble Space Telescope, we have seen the furthest galaxy ever, GN-Z11, which is approximately 13.4 billion light-years away. Scientists using the Subaru Telescope, the Vista Telescope, the UK Infrared Telescope, and the Spitzer Space Telescope were able to, studying redshift, a phenomenon in which light waves stretch out or become redder as an object moves away from the observer, determine that there was a very, very distant object in the sky, which they named HD1. This object could possibly be 13.5 billion light-years away. It was also said that HD1 could be a supermassive black hole, with a mass of about 100 million times that of the Sun. It has been left as a possible galaxy until the James Webb Space Telescope goes for a little investigation. The phrase visual acuity refers to the clarity of your vision. Experts consider normal or healthy visual acuity to be 20/20 vision. That simply means that you can clearly see something 20 feet away that you should be able to see from that distance. For example, if you have 20 out of 100 vision, you would still be able to see an object clearly from 20 feet away, but someone with normal vision would see it clearly from 100 feet away. Conversely, if you have 20/12 vision, you can see something clearly at 20 feet that most people need to be 12 feet from to see clearly. So, how does the eye process images? When you look at anything, a rapid and complex sequence of actions will take place in the eye and the brain. So, first, light reflects off an object and passes through the cornea, which is the transparent outer layer of your eye. The cornea bends the light rays to allow them to enter the pupil, or the dark center of the eye. At the same time, the muscles in the iris, the coloured area around the pupil, control the size of the pupil, making it smaller in bright light and larger in a darker setting. Light rays then pass through the lens, which sharpens them as they reach the retina. The thin tissue layer at the back of the eye that contains nerve cells known as rods and cones. The rods and cones convert the light rays into electrical impulses, and these travel from the eye through the optic nerve into the brain, which converts them into images. So, assuming that all of your body parts and processes that are necessary for clear vision are working correctly, then the only limitations on how far you can see come down to your line of sight, the amount of light on the object that you are trying to view, the size of the object that you're viewing, and the curvature of the Earth. And so guys, there we go. It's the end of the episode. I hope you can appreciate the amount of effort that went into this episode. You know, I'm trying to increase production quality video upon video. So it obviously didn't take me a whole 5 months to make. I will be getting back into making videos more frequently. However, there will not be an upload schedule. Anyway, if you enjoyed this video, share it to your friends. And this is Ice Caps. Wait, it's not Ice Caps anymore because I changed the channel name. This is Waffle with William signing off. See ya.
Subscribe.